The square of an integer is called a perfect square. We're going to generate the first 10 perfect squares below. Remember, when we square a number, 1 squared is not 1 times 2. It is 1 times 1. So again, it is the number 1 appearing as a factor twice. That's considered our base. So our base appears as a factor twice if it's squared. So 1 times 1 is 1. 2 squared is 2 times 2, which is 4. 3 squared is 3 times 3, which is 9. 4 squared is 4 times 4, which is 16. 5 squared is 5 times 5, which is 25. 6 squared is 6 times 6, which is 36. 7 squared is 7 times 7, which is 49. 8 squared is 8 times 8, which is 64. 9 squared is 9 times 9, which is 81. And 10 squared is 10 times 10, which is 100. So here are the first 10 perfect squares. So when you hear me reference, or if you hear anyone reference perfect squares, it is, again, the result of an integer being squared. Let's take a look at now square roots. The opposite of squaring a number, so when we square a number, we multiply it by itself. The opposite of squaring a number is finding its square root. Positive numbers have 2 square roots. Why? What numbers can you square to get 16? Let's think about it. We can do 4 squared, which is 4 times 4, to get 16. But we can also do negative 4 squared, meaning negative 4 times negative 4. A negative times a negative is a positive. So again, we get 2 answers. The answer would be negative 4 or 4. Sometimes you may see it written out as plus or minus 4. That shows positive 4 and negative 4. All right, negative numbers have 0 square roots. What number? All right, so let's talk about that. Why would a negative number have no square root? Let's think about it. The square root of negative 16. What number times itself will give you negative 16? No number, because 4 times 4 is positive 16. Negative 4 times negative 4 is positive 16. Remember, it must be the same number, so it can't be negative 4 times positive 4. So there are 0 square roots for a negative number. And what number only has 1 square root? 0. All right, so 0 squared is 0. It only has 1 square root. No such thing as a positive or a negative. 0, 0 is 0. It is neutral, remember? Let's talk about the radical sign. All right, so this is radical x. It is used to indicate the square root of. So when you see this radical, when it's just like this, it means square root of. So this is the square root of x. Square root of x can be used to indicate the positive square root of x. Why? Because x there is positive. All right, let's take a look at the next one. Remember, there's a negative on the outside. So when we see a negative on the outside, remember, we can always think about it as opposite of. So the opposite of the square root of x, right? This is actually going to, and this is used to indicate the negative square root of x. Why? Because remember, you're actually taking the square root first. So if I were to give you this example, this says negative square root of 16, or opposite of the square root of 16. You find the square root first, which is 4, and then you attach the negative. All right, because it says the opposite of whatever that square root is. All right, let's continue on. Here are a few examples. Can we think of a number times itself to give us 49? Very good, 7, because 7 times itself is 49. What about 9? What number times itself gives us 9? 3. Very good. All right. What is the opposite of the square root of 4? So first you find the square root of 4, which is 2, and then you drop down your negative. So negative 2 is the opposite of the square root of 2. All right. So now we need to find the opposite of the square root of 289. 17 times 17 is 289. And this says the opposite of that square root. So that gives us negative 17. Moving on now to the opposite of 196, the opposite of the square root of 196, or negative square root of 196. What number times itself gives us 196? It's 14. And the opposite of 14 is negative 14. All right, now the square root of 484. What number times itself gives us 484? 22. All right, and now we see here it appears to be a fraction, but don't be afraid. We can break this out, and we can actually look at it as the square root of 1 divided by the square root of 16. All right, or over the square root of 16. Square root of 1 is 1. Square root of 16 is 4. So the final answer is 1/4. All right, this one says the opposite of the square root of 81 25ths. So we want to do the opposite of the square root of 81 and the square root of 25. All right, so we know that square root of 81 is 9, square root of 25 is 5, and the opposite of that is negative. So negative 9/5. And finally here, we have the square root of 49 over 144. Remember, you can break it out as square root of 49 over square root of 144. And when you do that, you'd end up with 7/12 as your final answer. Perfect versus non-perfect. Let's take a look here and see if we can find some perfect squares. Remember, perfect squares are the result of an integer times itself. Is there a number times itself to give us 9? Yes, 3. So 3 times 3 is 9. Is there anything times itself to give us 32? No. Anything times itself to give us 121? Yes, 11. We'll put these down for reference. What about 1? Is 1 a perfect square? Yes, because 1 squared is 1. Is there a number times itself to give us 160? No. What about 64? 8 times itself is 64. 200? No number times itself to give us 200. What about 324? 324 is a perfect square, which is the result of 18 squared. So we have 5 perfect squares identified below.